Our mission was to prove or disprove that the Barberton area held the origins of life. Who better to ask than geologists, professors and twin brothers Richard and Maurice Viljoen, who began working in this region in the 1960s.
We're in a very special place as far as we're concerned. It's the southern part of the Barberton Mountains, mountain land, and through it runs the Komati River, which you can see in the background. And to the right of the river, you'll notice some hills, and if you look carefully, you'll see some lines on those hills. Those lines are the lines of a number of very ancient lava flows. But these are not normal lavas. These are very unusual lavas. They were first identified in this area, and they are called Komatiites after the Komati River. And they represent some of the first lavas erupted onto the planet. Their age is about 3.5 billion years, and they are pretty unique, and they've been found now in all the ancient continental areas of the Earth.
The Barberton Mountain offers the perfect opportunity to go back to the beginning of Earth's history. The rocks hold the key to understanding early life.
One finds a black, what we call a carbonaceous silica-rich rock called a chert, which I'm holding here. And it's in these rocks, which are older than 3.5 billion years, that scientists have now found signs of primitive life. Pretty close to the origin of life, we believe. And for this reason, and these cherts are fairly common in parts of the Barberton belt, for this reason Barberton has been called the cradle of life. That is why. Because of the life forms which are similar to present-day bacteria and algae that have been found in them.
Even in the 1960s, NASA knew that these might very well be the oldest rocks on the planet. The Barberton Mountain is a treasure trove of geological history that reveals much about the formation of Earth as we know it.
So in the background, we will see a large granite dome. And that granite dome belongs to a suite of granites which are dated at about 3.3 billion years. And they were the first granitic rocks to intrude the essentially Komatiite-dominated early oceanic-type crust on the Earth. So they're intrusive into the 3.5 billion year old Komatiites. And they contain xenoliths or inclusions of the Komatiite. They're full of these inclusions of Komatiitic material, and it's an unequivocal intrusive relationship. The granites are essentially quite distinctive. They're light in color. They're composed of sodium-rich feldspar mineral, a translucent mineral quartz, and also mica, generally biotite mica. And they're generally fairly easily eroded or weathered. However, they do form these distinctive domes, whaleback domes of the type we've mentioned, due to exfoliation and also spheroidal weathering, which are classically developed on these domes, also called monoliths, if they're just one big single dome.
When these rocks in Barberton were formed, the entire Earth was covered in water. These rocks were formed by underwater volcanic eruptions. Another interesting Komati formation are these magnesium-rich rocks that resemble tombstones.
What we're looking at here in the background is this somewhat sheared rock, very magnesium-rich Komatiite basalt, very high in magnesium, and it tends to shear and to give rise to a very distinctive kind of weathering, which is called tombstone-type weathering, which you can see very clearly in the background here. And to demonstrate the rock, it's a fairly light greenish-grey coloured rock, which you can see over here. And to show how soft it is, this is a geological hammer. If I scratch, you can actually scratch this very easily because of the soft magnesium minerals that have formed in this basalt. So this type of rock forms the upper part of the Komati Formation, very magnesium-rich basalts, Komatiite basalts, with a very distinctive composition as well.
After a long day of giving us a tour of the Barberton area, the brothers went on a tour of their own to discover more about the famous gold mining in the area.
Galaxy Gold Mine was bought on auction in 2008, and we started with mining production halfway through 2009. So this mine has a small-scale operation, and it's privately owned by a consortium of friends from the Johannesburg area. So what we're going to be doing is we're going into a mine that's dated 130 years old this year. It's the Pioneer Mine. It was the first mine that was discovered in the Barberton district, and gold was actually discovered here in 1871 by a gentleman with the name of Thomas McLachlan, who came through to Barberton and then founded gold. And then later on in 1882, French Bob Augustus Roubaix came through this creek that we see over here, and then he found alluvial gold, and eventually which led him to reef gold.
150 meters into the mountain, the aim of the tour is to give visitors an idea of early mining practices, but the Viljoen brothers were naturally more interested in the rock formations. Scientists believe these rocks are one of the oldest and best preserved volcanic sedimentary series in the world. Empirical evidence that makes Barberton home to some of the planet's oldest known rocks where early life was formed. A quest fulfilled.
The Barberton-Markondra mountain land is truly unique, containing the oldest and best preserved sequence of volcanic and sedimentary rocks on Earth. They have provided an unparalleled source of scientific information on the formation of the early Earth from 3.6 billion years ago. Joining me now is Professor Terence McCarthy from Wits University. Professor, thank you so much for joining us. Now, I got very excited earlier this week when one of my producers said they had a rock at my desk. I immediately thought diamonds, and this is what I found, but I'm told this is over 3.5 billion years old. What would a rock like this actually tell us about the Earth?
Well, you know, a rock is to all of us just a lump of hard stuff, but in actual fact a rock is like a time capsule, because when it forms, every rock has got an age. It forms at a particular time, and when it forms, it captures information about the world that it forms in and the processes that give rise to it. So by learning to understand the way rocks form and being able to read the message that they contain, we can actually deduce quite a lot about the world in the past. So it's like a time machine, actually. Rocks enable us to go back in time. And the Barberton is particularly important because, as you said in your introduction, it's the best preserved of the oldest sequence of rocks in the world. There are older rocks in the world. The oldest rock in the world that's known, actual rock, is about 4,200 million years from northern Canada. But that's just a boring lump of rock, no particular interest in it. Then there's some rather interesting sedimentary rocks in Greenland, not a particularly large amount, but they are about 3,800 million years, and they are very, very important in the whole history of life and story of Earth. And then Barberton. Barberton is of the oldest rocks, the really old rocks, over 3,000 million. Barberton is the best preserved.
But how do you get to quantify that number? How do you know that a rock is 3.6 billion years old?
That's a very good question. So when a rock forms, particularly a rock that forms from a lava, for example, from a volcano, it pours out of the volcano, and it starts out life as a completely molten state. And as it solidifies, it forms little grains of what we call minerals, little chemical compounds. And some of those minerals trap inside them small amounts of atoms that are radioactive. And these then decay. So when it forms, it sets the clock at 0. And then over time, the radioactivity causes, for example, uranium to change into lead. So we come along today, we isolate these little grains, we measure the amount of lead that's accumulated, because they didn't have any lead to begin with, and how much uranium is left, and from that we know the rate at which it changes. We can work out the age.
Let's look at the potential of the relationship between geology and tourism, and whether we're doing enough in South Africa to bring the two together.
Well, we probably aren't. You know, the Barberton Trail is a wonderful new departure, new venture, really, because it's bringing to life and bringing to the public attention these fantastic geological things that we have in South Africa. But it's just we have the most amazing geological history preserved here, probably better than anywhere else in the world, because we go from Barberton 3,600 million years. We have the whole story of preserved in our rocks. We have almost continuous rock formation going back to 3,600 million years. So we've got the most incredible story of early life, of the way the Earth has evolved from its very primitive state, right through to the development of the atmosphere, free oxygen in the atmosphere. We have that story preserved here, right through to the development of more advanced life forms, and origin of dinosaurs, the origin of mammals, and of course right through to the origin of man, ourselves, our species in the cradle of humankind. So we have a record of geological and paleontological and fossil record that is unparalleled anywhere in the world, absolutely anywhere. This is unique. But there are very few trails that have been created specifically to show this to the public, to interested people. And the Barberton is the first one that's really important. And one can only hope that there are more, because there's an amazing amount to see in South Africa.
I mean, when we were chatting earlier, both you and I have realized that we both haven't been on the Barberton Trail.
That's correct,
but there is immense opportunity in terms of tourism potential that the Barberton Trail and others can attract.
Absolutely.
What do you think needs to be done to ensure that we're attracting people to these sites?
Well, I think the important thing is for people to be aware of them, and for the geological profession basically to create the vehicles to popularize and to put it in a way that can be understood. We've tried to do this on a countrywide scale, not as a tour. With this book here, Story of Earth and Life. There's another very nice book called Geological Journeys, which is it describes the geology along various highways in South Africa. That's a really interesting read for people who want, sort of roadside geology. And then, of course, the Pilanesberg has been quite well documented, but they've sort of isolated little patches. Barberton is now well documented, but there are lots of other potentially interesting places. The Drakensberg would be wonderful.
Let's talk a little bit about the books, and then again, in a quick conversation that we heard earlier, you had me enthralled talking about how the Earth's surface moves so that we have continents and oceans. Tell me a little bit more about what are you hoping to achieve with these two publications?
Well, these publications are really just to explain the wonders of the geological environment to the world at large. They're not technical books. They're written for the general reader, and we try to make things as simple as possible, with cutting out all the scientific jargon and just telling the story, because it's a fantastic story. The rocks themselves are revealing the most amazing things. For example, let me tell you a little bit about Barberton. As a case in point. The world was very different then, and we've learned this from the rocks. For example, atmospheric pressure atmospheric pressure on Earth today is 1 bar. 1 bar, right?
Okay.
Atmospheric pressure in the time those rocks at Barberton, which you see on the trail, formed, was somewhere between 30 and 90 bars. That's equivalent to the depth of between 300 and 900 meters underwater. It's an environment that would crush a submarine. Submarines can't go to those depths. The atmospheric pressure was amazing. There was probably, the moon was much, much closer. So the full moon would have almost filled the night sky.
More romantic
evenings. Absolutely. The moon has steadily been spiraling away from the Earth. The day length was only about 14 hours. The temperature of Earth, we're not sure. The sun was much dimmer, but the Earth was quite warm because it probably never had ice caps, because it was of the greenhouse effect. And this was an environment which a human being, if we went back in time into that environment, you wouldn't last a second. It would just kill you. But there were bacteria living then, and they preserved in fossils, like for wood fossilize. They get preserved in silica, and we see those at Barberton. The incredibly ancient bacteria. It was the most advanced life form in those days, and that bacteria was steadily working its way to modify the world into the world we see today.
So let me have my rock back, because it's clearly more valuable than I thought.
That story is encapsulated in the rocks at Barberton, that very, very early chapter of the Earth. And at that stage, the Earth was under serious bombardment from space. There were these massive asteroids that were colliding with and showering debris all over the planet, and we see the layers that they formed in the rocks at Barberton. It's absolutely amazing.
Professor, thank you so much for that beautiful narrative and your insights today. Of course, that was Professor Terence McCarthy, and he has shared with me that this 3.5 billion year-old rock possibly could be worth a couple of millions in a few years. So I'll be holding on to this baby for much longer.